evil creature of the night, killer of mouse and other vermins. I got you! Ha ha! You can't flee away from me! You can't!
Hey, ain't you here? Oops, there's a sword here. You know what this is good for? Chasing bugs. Debugging, that's called. Debugging. Hardware debugging. There is something like software debugging, which is kind of weird because you're debugging software. It is software debugging. But here we're talking about hardware debugging, which means that your code is actually running on the device you want to run it on, and then you can check and see whether everything's going fine or not. And in this particular case, we're talking about own Arduino boards, of course, and only using the USB cable. So no special hardware whatsoever. If you own an ESP8266, you ever programmed it, or you own a Zero, you ever programmed it, then you've got all the hardware at home you need to do hardware debugging. These are the only two boards for now. And this is an impressive sword. So, there is a small thing to know. ESP8266 only works with version 1.6.5 for now. We're trying to find out what's going on. There is a difference between the two in the sense that if you want to debug ESP8266, you have to change your code a bit here and there. You actually have to include the GDB stub library to make it all easy. We bundle that in another library which is called GDB, which you can find on GitHub Jantje libraries. Yeah. And the Zero, you actually have to do no changes of your code at all. You can just whoop through it. For the techies, I don't understand what it means, but the ESP only has one breakpoint and the Zero has 4 breakpoints. Not sure why, because you can step through your code, but anyway, both of them need, of course, other compiler commands to include the source code. And this include the debugging information so that the debugger can tell you what's going on and give you the information. So you have to have other compiler commands. And I did not go for an option menu debug and not debug because that was way too complex and too complicated. I actually just created other boards, which are basically the same boards but just with other compiler commands. And these boards you can find again on GitHub Jantje hardware. So if you have this repository and this repository on your system, and you have Sloeber version 4, and you have one of these boards and a USB cable connected to your system, you're ready to go and do some debugging. Let me show you how.
Debugging the ESP8266 with Sloeber. And we're going to go the whole way, which means that we will install Sloeber, we will install the ESP8266 stuff, the newest ESP boards. Then we will create, build and upload a blank sketch for the ESP board. And then, which is I think the most logical situation, you've got something and then you decide you want to debug it. So then we'll go for debugging. So let's first start with the first part. We go to sloeber.io, which translates to eclipse.binds.it. We click the install button. The table is currently still 3.1, so we need to install the nightly. We go here, and we need the very last one, so we scroll all the way down because in 32 I am using the 64-bit version. Download it. So starting with 7-zip, extract here, then here 7-zip, extract files, and we're going to use C:\tests. Okay, this is a brand new folder which does not exist yet. See test here. Sloeber, Sloeber.exe. Now the rest of the installation process. And we go Windows Preferences. We're going to install the newest ESP stuff. The newest one. Okay. Again, we wait. Now we can make the blink sketch for the ESP port. I have Node MC 1.0, so I have to take this one. Don't ask me why I take these values. I don't know. Next, we go for sample program, and we take the examples basic blink finish, and now we can upload and build and upload. So we now here we created a VIC, and we now assume we have a bug, and we decide we want to debug this thing. The first thing we have to do is to install the Eindjes board. Yeah. To do this, we go to the browser. Yeah, we go to GitHub. hub.com/Jantje. And there you have the hardware, and you click clone or download, and you download it. You can also import in your project if you want with using the GitHub functionality. I might make a video about that one day as well, but not right now. So we have here this master zip. So we're going to extract that one. Oops. X7 zip. Extract here. So we have now this folder, and you have to see the hardware here. ESP, AVR, local, and SUMD. So we copy this one. We go back to Sloeber, and we add the boards to Sloeber by adding the location to and this one is empty, and that gives warnings. Okay, so now we can create a new sketch. Based on this one here. And we're going to go to the GDB, blink, finish, and we get an error. We're here. So what we happened is we installed the boards, we create a new create a new project. But anyway, why did the build fail? Because we installed the newest ESP8266 and the debug currently needs 165. So what do? We install 165. Those preferences, Arduino, platforms and boards, ESP, and you actually need both of them. How could you have known which version you need it is if you look at the properties of this core, you actually see here 165 minus. This basically tells you that this one is needed and it's not there. Okay, already says now it's there because it's already installed, but that was the problem. Yeah, so it's installed now. We can rebuild. It's still not working because there's other things missing than purely the file locations. The files were missing as well. So we click apply, okay, and we can build. So that works. Now the problem with working with two projects is that actually you have your code here. You want to modify this blink.ini, you don't want to debug this blink.ini. So you don't want to have two projects. So it only takes two projects to demonstrate that it works. So what you actually want is you want to build a new configuration. And you got debug. Yeah, okay. And now we say, oops, no, we're still in release here. Don't forget to switch to debug. And we go here to the Yanch location. Okay. Now, you can here set build configurations, set active, still on release, we're going to debug. Now, if we compile, even though it compiles fine and stuff like that, you will not be able to debug it because for debugging with ESP, you need to add some extra stuff. So first of all, these things here is because there is no include. You want to include gdb.h and probably also Arduino.h, but gdb.h includes Arduino, I think, doesn't it? So g.b.h, because we added it, it's added here. I'm going to include Arduino as well. So that's one part you have to do, and for all the functions you want to debug, and that's basically setup and run, you need to add this romp func specification. And you also need to add this at the beginning of your setup. You notice there's already a define with if-def debug to make things hide away when you switch. Okay, we're gonna get rid of this one. We're going to upload this one, and now we're going to delete this one as well. Up. In the meantime, it's uploading here. And it's uploaded. Now we're going to go to debug as, debug configurations. So you need the remote application. So we create a new one. You say blink here. Search the project. If he doesn't find it himself, you say disable auto build because that's not useful. Now the executable itself is in the package we downloaded, but this is the Windows version. If we get another OS versions, we can add them as well, but for now there's only the Windows version. For the other one, we need this command file, which I think is OS independent. And in the debugger here, you better write setup. And then you need here the connection. You need to set it to serial. And then of course you need to /point/ and then the com and 11.520. The rest is the same. So he asks you whether you want to go to debug perspective. Here you see the perspectives we currently have, and he's going to open another one which is specifically made for debugging. So here we are in the debug perspective. So we're going to put a breakpoint here, and here we are. The debugger is here, and now we can you see here just the commands: step return, step over, step into. So if you do step into, this is actually the core code which is doing the delay, and you can go and see what it actually does. Let's do F7, or just do F8. Now basically you should only debug stuff with romfunc as far as I understood, but you could, it's not as stable as the Zero debugging. So but it works. You can actually step through your code and look at the registers and stuff like that. For instance, here you see registers, you see the general registers, you can see their values. Here you can see the values, all stuff I don't really understand. Hardware specialists do know far more about that than I do. Here you see your breakpoints, and if you have variables, but we don't have any variables here in this situation, you can look at them as well. Oh, and that's how you can debug. We don't want the debug version to run on our ESP, so we basically go back to the release configuration. So we go in build configurations, set active, release, and we recompile. And as you can see, that's not good because he doesn't find GDB. Now, the thing is, this part of code we can easily disable with the if-def, but romfunc is actually not defined anywhere. And Eclipse is a bit confused now because this GDB is actually the old GDB from the hardware inclusions. This one shouldn't be here. Yeah, so we need another library which mimics this library, and therefore I created in my Arduino libraries. Again, we go download zip. You only need this one, so for this particular thing, but there's other interesting stuff in here. So, and that GDB libraries here, 7-zip extract here, and then we have the Arduino libraries master, copy back to Sloeber, Windows preferences, and just like we added the hardware here, we add the library here. And just like we actually remove the defaults where nothing is on my system, we can remove this one here as well. So now if we Arduino reattach libraries, you see now that it's a completely different GDBC, which is now actually located in my downloads folder. Yeah. And now this romfunc is now defined as nothing. The indexer has not yet understood what's going on, so let's rebuild the index. In the meantime, let's rebuild the program. So now the program compiles. In the romfunc is still defined as nothing here. So we now back to release, and we actually have disable this function, and ramfunct is not defined as nothing. So we have our production code back in the same way, the same source as we have our debugging. That's it, and don't forget to sponsor me on Patreon. Thank you.